So students, we continue with the smallest integer function. The extension we did up to this greatest integer. So here we are smallest integer function, we are over here. So this is also known as a ceiling function. Ceiling function, the same function has got two names and it is represented like this, a hook like this. Okay, now what it means? It means something like this. It's the opposite to what we got in greatest integer function. So it will be something like, if you get 2.9 and it will be considered as the right hand side integer, so it will be a 3. So I told you, if it is a 2.9, so you get two integers on the two sides. Here smallest integer function, it will be a right hand side integer you have to take. So if it is something like say 2.1 also, it will be 3, because the right hand side of 2.1 is 3. Now if you put some negative value like minus 1.6, so it will be right side value is minus 1. Okay, and obviously any integer if you put like say minus 4, so this value will be same as minus 4 only. Okay, so this is the simple thing, and this graph will also be a stair looking graph, a step kind of thing. So let us draw. So if these are the values, okay, so what we know that between, if it is something like, first you start like this, if it is something like 0.1, if it is something like 0.1, it will be 1. So that means if it is 0, then it is 0. So it will exclude the left integer and move till this. Now again it will start from here excluding this one on the two bracket, it will move. So it will move like this. See, if there is a 3 over here, so it will start excluding 3 and it will move up to 3. Okay, so this is the thing. And here in the negative direction, obviously it will be this, it will move up to 0 excluding minus 1, and here excluding minus 2, it will move up to this. Okay, so this is the kind of thing which we get for the smallest integer function. My suggestion to you is that you better you do this, try play with the values, few values, draw it in your own copy, then only you can get a better feel of this. Okay, so here also what we find, we get all the y's as positive integers or negative integers. Okay, here I wrote a minus 4. Okay, so positive or negative integers. So definitely, so the range of this, the RF will be an integer over here, and the DF can be, that means domain can be any value. So the domain is R, that means it's taking any value. So the domain is basically R, so all real values. So this is all with the smallest integer function or the ceiling function. Next we will start with fractional part function. Okay, the fractional part function we write like this, y equals to this thing. So it's actually what happens, I'll tell you first, give you the example. It's only the fraction considered. So that means if you get something like 2.75, it will be 0.75. Okay, so this will be the answer. That means only the fraction part of this is getting considered. Now if you get something like 2.10, it will be 0.10. Okay, now obviously if you get something like 2, it will be 2. Okay, now regarding the negative things, say I get something like minus 2.8. Okay, minus 2.8 means a minus 3 have to be subtracted from here. So that means it becomes minus 2.8 minus of minus 3, that means you get a plus 3, so 0.2. Okay, so since things like this only, so you get minus 2.1, so minus 2.1 will be 0.9, things like this. So we can also express this as x minus box x minus box x. So if you subtract the box x, that means the greatest integer function, from x, you will get this value. So if you draw this, so before drawing only you can understand that y is very fractional, so y cannot be 1, it cannot touch 1. So here if there is a value like 0, 1, and these are the all values, possible values on the x-axis. So these are the possible values on the x-axis you get. So 1, 2, 3, 4, 5 and on. And here minus 1, minus 2, such and such, minus 3 say. Okay, so these are the values. My drawing is not good. Okay. So what will happen when I draw this? 0 will give you 0. Remember, 0 will give you 0. So this value is taken. But if I put 1, that also will give you 0. That means this point, that means this line, if you consider 1, this point is not taken. It moves up to this, like this. And why it is a kind of sloping straight line? Okay, because see, it look at this, it's y equals to x sometimes, so it becomes kind of sloping straight line. So this also 2 value it cannot take, because if it is 2 it becomes 0. If it is 2 it becomes actually 0. It's not 2, it becomes 0 actually. So if it is 2 it becomes 0. So please mind it. So I wrote it wrongly actually. So here whatever you do, you exclude the last point of it. Here also you start with minus 1, you exclude this point. Minus 2, exclude this minus 1 point. Like that it will look. Now obviously we see that the y part, that means the RF part, is some kind of a fraction part. So that means it will be something from 0 to 1. It will be something from 0 to 1. Obviously there is a closed open interval. Closed open interval denotes what? Closed open interval denotes a fraction. Whereas the domain, it can take up any values, it will be R. The domain, it can take up any values, so domain will be R. So this is all with the fractional part function. Now let us start with the exponential function, few exponential function. So here I have drawn an exponential function. So y equals to ax, y equals to a to the power ax. So here the value of a I took greater than 1. So the graph will look like this. It will cross this point 0, 1 and it will look like this. Okay. So as you can see that x can be anything, so you can get the domain f as anything, like anything you can put for this. So you know from the exponent rule that if x is negative, a to the power minus 2, okay, then it will be also 1 by a square. But still it is positive. So y is always positive, y is never negative. So this range, it never goes down below 0. So it will be something like this. Okay. So this is actually the domain of exponential function y equals to a to the power x, a greater than 1. Now another situation we see where a to the power x and A is between 0 and 1. Here what we find, the graph will decrease like this. Okay, still it will cross the point 0, 1, and here the value of A is, remember this. So here also the same domain and same range will be there. As you can see that y is not coming below the x-axis, that means not non-negative, and x can have negative and as well as positive values. So next we will see the square functions, the cubic functions, the square root functions, all those things we will try to draw. So we will write it on the board and continue. So the next function we get is the reciprocal function. Reciprocal function I have written 9. So that is the reciprocal function you get as y equals to 1 by x. The graph looks like this. That means this line will never touch the axis. These lines will never touch the axis. It means that never touching the axis means it will never become 0. Okay, so here also you find that, see, if x is 0, what happens? It becomes y gets undefined, and if you write it in the reverse way, x equals to 1 by y, then also if y becomes 0, then x gets undefined. So undefined things are not to be considered. Why? We are dealing with real functions. Okay, we are not dealing with non-real or something like that, imaginary things. So undefined things we are not going to consider. So obviously this kind of graph where the domain will be all kind of positive and negative numbers are, but is not 0. That means not 0. So r minus 0 restriction is there. Even the range is also same, r minus 0. That means apart from 0, except 0, we can have all possible real number values. So that is the domain and range for the reciprocal function. Next we see the square function. Square function is something like number 10. So y equals to x squared. This will give you a parabolic kind of curve. So parabola. So this you will learn in next in the chapter of conics mainly. So now for the time being, you just see, if you draw the curve by taking suitable values, you will find that the u kind of curve is getting generated. So it touches basically the origin and moves towards up. So these are the axes and you get the curve like this. So basically x can be any values, you can put anything for x. So the domain becomes R. But as you see, y is always up, 0 and up. So range will be 0 to infinity. That means from closed open interval. Range is closed open interval from 0 to infinity. So this is all with the square function. So next we discuss the square root function. The square root function is y equals to root x, or you can say this is x to the power half. Now if you remember, in the previous parts we discussed that if root x is there, it fails to be a function because it produces two kind of images and it mainly violates the second rule. That means if 4 is there, it produces what? 2 and minus 2, just producing 4, 2 and 4 minus 2, two ordered pairs with the same first element. So this is not a function. Okay, this we learned. So if you do not remember, go through the previous videos. Excuse me. So here what we do, we need to take care of this situation. This happens. So we will exclude this part. The negative part we are excluding. So we are trying to draw the graph in something like this way. The graph will be actually like this. Okay, the graph will be something like this if you try to draw. But since this cannot be a function, we remove this part. So it's very important. We remove this part. So only this is our graph. Okay. So if this is the x-axis 0, then y-axis, so the graph will be this. Okay, so the domain of this, you can put any value for this, so it will be R, and the range of this is positive since we have excluded. So 9 gives what? 3 and minus 3. So what we are doing, we are cancelling the negative parts, because if we keep the negative part, then the rule number 2 will be violated. Okay, so RF is basically 0 to infinity, the closed open interval. So it's 0 to infinity. So this is the square root function, its graph, and its domain and range. So next we see the cubic function or the cube function. So here y equals to x cube. So write cubic function. Okay, so it will be, okay, a graph like this. Okay, it will be a graph like this. So it's not a problem. If you put minus, it will give you minus. If you put minus 2, it will give you minus 8. So basically all the possible numbers forming including 0. So it's very simple. DF is R also and RF is R also. Say if the next is cube root function. Cube root function will be y equals to x to the power 1/3. Y equals to x to the power 1/3. That is the cube root function. So that graph is it's a kind of graph. You see, it's S kind of graph. This kind of graph you will get. So this is also the cube root function. Here also there is no problem. You can see that x increases and decreases along with y increases and decreases. So here also you can get the domain and the range both as R. So these are the basic kind of real functions graph which we have discussed. So apart from this, we have got many situations where two graphs are combined and we need to draw the graphs. So it's always better or advisable that you practice the graphs, get the domain and range, and next time what we will do, we will try the algebraic methods to sort out the domain and range of functions, real functions only. So this was the graphical method by which we analyze the graph and see the domain and range of it. So thank you. Next time we are going to solve the domain and range sums from the real functions.